Hello, welcome everyone to this week's DevOps Chat, where I am thrilled, honored, delighted to have kind of one of my heroes from when I was learning to code, Steve McConnell, joining us. Steve, thank you so much for taking some time out to talk with us.
Thank you for having me.
So I guess, the first real recollection I have of your work was when I had a copy of your fantastic book, Code Complete. I had it on my desk when I started work, and every day I would read one chapter, and after a month or so, I learnt just so much about coding, and that has stayed with me really for my entire career to date. You know, it's been one of the most influential books I think that I've ever read. So again, I suppose personally, I just want to thank you for that.
Well, thank you for thanking me on that. That description is actually a lot of why I wrote the book in the first place. I felt like I had learned a lot of lessons the hard way, and I felt like there had to be a way to short circuit that experience. So the way you went about using the book was actually exactly the way I was hoping people would use it.
So I was going to say, so maybe just let's jump right in there with some of, as you say, so your motivation was to help people learn how to code better based on your hard-won experience?
I think I was pretty typical at the time in that I had a professional experience, and I had kind of in the meantime picked up a master's degree in software engineering, but I got most of my work experience prior to writing Code Complete without any real formal background in computer science or software engineering. And I was pretty representative of people working in the field at the time, which was there were a lot of people who came into the field from engineering or math or science or literature or philosophy or business or whatnot. And so a lot of those people had either had only a couple of computer science classes or maybe no computer science classes. Code Complete is not a computer science book really, but there were a lot of people who really were just kind of making it up as they went along. And that's really what I'd had to do too. And there were larger organizations that provided some level of support for their professional staffs, but not very many. And there were most small organizations provided zero support for their professional staff. So I really felt like there had to be an easier way for people to get up to speed on what it really meant to be a professional programmer. And so that was really what I was trying to accomplish with Code Complete, was to distill what somebody needed to be able to be a competent programmer. It's funny to say distill when you're talking about a 1,000-page book, but that really goes to the point that programming is maybe it's not heart surgery, but it's still pretty complicated, and there's a lot that someone needs to know to be a competent practitioner in the field.
Yeah, wow. So I guess it's one of my there's so much I still remember to this day from the books. I remember advice about how to structure a routine, advice about how to comment routines, not having comments that just describe exactly what the next line is doing, but going to a higher level of abstraction. Are there any things that, that book is, it came out 24 years ago. So I kind of think there can't be many books about a technical subject that still have relevance that amount of time later.
Yeah.
But are there any kind of key parts that you look at from that book and you think, wow, that's still just as relevant today as it was 24 years ago?
Yeah. Well, the first edition came out 24 years ago, and then I updated it significantly in the second edition, which came out 13 years ago. There were definitely things that changed between the first edition and the second edition, for example. I think, when I got into working on the second edition, I was kind of surprised because I really felt like there would be certain topics that I would add as chapters in the revised book. For example, in the first edition, the prevailing design and coding mode was structured design and structured programming. And by the time I got to the second edition, the prevailing design and coding mode was object-oriented design and object-oriented programming. And I thought initially I would treat that as a chapter in the book, but what I realized as I got into the second edition was that it was such a pervasive change that I didn't need a chapter at all. It actually just rippled through all the other chapters. In a way, the change was simultaneously deeper, but also more subtle than I had realized. And likewise, in the first edition, I had a chapter on evolutionary and incremental development as a chapter, basically. And by the second edition, that wasn't needed anymore because agile programming had become popular, and the idea of incremental and evolutionary development was on everybody's radar screen by then. So I think the first edition was really kind of an attempt to capture things that hadn't been captured in writing in a good way. The chapter specifically, or actually it wasn't a chapter, it was a section on incremental development, was needed at the time because nobody else was really talking about it in a digestible way. By the second edition, everybody was talking about it, and it was actually a little peripheral to the main subject of the book, so it just wasn't really needed at that point. I think it's interesting to me that today, I think, even though the second edition is now 13 years old, I don't think it's anywhere near as out of date after 13 years as the first edition was.
Right, okay.
And some of that is just the idea, there's this idea in the reuse community that you have to develop something 3 times before you make it completely reusable. Some of it is probably just the hardening effect of going through a second edition. And then I think some of the technology has actually been somewhat more stable over the last 13 years. We're still doing a lot of programming in the C family of languages, whether it's C# or C++. Java, in my mind, is still kind of in the C family of languages. We still see a lot of VB programming. I think the thing that's not addressed in the second edition that really, if I were to write it today, would have to be addressed is scripting. And so, that's essentially ignored completely in Code Complete. And I think that would be impossible to ignore if you were writing a book like that today.
Yeah, I suppose dynamic languages, untyped languages, languages that don't compile, they're much more prevalent now than they were. I'm just thinking, where are we, 2017? So certainly in the early 2000s, that was not a common approach to programming, was it?
No, and the funny thing is, it's one of the patterns I've identified, and I don't think I talk about this in Code Complete, but the software world has gone in technology waves, and I've been doing this long enough now that I've seen multiple iterations of the idea that everything old is new again. And this idea of weakly typed languages and languages that don't compile and so on, well, that's where I started my career in the early to mid 1980s. And so there clearly are practices and families of practices that work well when you're working with those kinds of environments. Of course, the technology today is vastly superior to the technology in the early to mid 1980s. But I think a lot of the issues that you run into, basically the issues with weakly typed languages, or the advantages of working without needing a compiler and so on. There are some generalities there that would still be relevant 30 years later. And I think that's one of the, that was one of my objectives in Code Complete, is I didn't want to write a technology book that would be obsolete 18 months after it was published. And so I really tried to focus on principles rather than the technology. The challenge with the field, of course, is that since it's a coding book, there's no real getting away from having examples in technology.
Yep.
And I think, too, what I've seen is that technical people tend to be pretty literal. And so, I might look at something and say, well, here's an example, and it's in COBOL, and it makes perfect sense how this would apply in Python. But an awful lot of people just don't see the connections there. And so I think the technology choices actually matter more than they should in a way. But, also when people are trying to learn something, you want to minimize the unfamiliar parts and maximize learning on the.
So I'm really interested in your view. This is almost like a bit of a tangent, but I've always felt a little bit that when, as a developer, you learn your first language, everything is the only way to do it.
Yeah.
There's no such thing as this is one way of looping. It's the way of looping.
Right.
And then but I think once you've learned 3 languages, then you start to think much more in generic terms of like a while construct or an if construct, and you tend to treat the language as a specific implementation of those slightly more abstract ideas. So I suppose my question would be, does that match your experience? But also, do you think is there value in people learning more than one language? Does it help them to code better, or does it really not make any difference?
Yeah, I think it absolutely. In fact, in both the first and the second edition, in the introduction to the book, I comment on the fact that learning a second language, sorry, my computer is almost about to reboot here. I comment on the fact that learning a second language well or deeply is typically a watershed event in the career of a practicing programmer, because that is when some of the light bulbs start to go off about, oh yeah, this isn't the only way to do it. It's just the way that, I learned to do it in, VB or C# or whatever. So I think that second language that you learn deeply is definitely a significant event in the career of a programmer. And in fact, in Code Complete, that's one of the reasons that I don't just use one programming language. Examples, I've got about 5 different languages that I use throughout the book. And part of that is to get people's minds wrapped around the idea that there are principles that transcend individual languages. And yeah, the syntax for a for loop looks this way in C# and it looks that way in VB or Java or whatever. But, the concept here is not so much the details of where I put the semicolon or whether I need a semicolon. It's just more about, what do I name the variables, and how do I do the indentation, and how long should my loop be anyway, and how cohesive should the internal contents of the loop be, and all kinds of stuff.
Which applies no matter what language you're coding in. So and the link for me into sort of DevOps for all of this is that I think DevOps and Agile before it as well, really, they place a high degree of importance on software craftsmanship. So the detail of how the lines of code are written. And I think, if I remember rightly, that's something you identify in the book as, so yes, you were filling this gap, but also you were saying exactly how you write and structure your code, it matters, it makes a difference. So could you just, as I say, perhaps reiterate your view on that?
Well, it's gratifying. It's gratifying to see this. I mean, I think that for a long time, I think coding was really the only thing that was guaranteed to be done on projects, but that didn't necessarily mean it was done well, or that people were prioritizing doing it well. It meant that it was often done in a sloppy way and in a hurry, and sometimes that's because people just didn't know any other way to do it. In the introduction to both editions of the book, I comment on the fact that other software development activities can be abbreviated or shortchanged, whether you're doing them in an agile way or a waterfallish way. You can kind of assume customer requirements, or you can actually go talk to the customers and understand them deeply. You can assume architecture and, change it all the time as you work your way through the project, or you can do a little bit of upfront work on it that might save you time later. But the one thing you're going to have to do if there's going to be working software is write some code. So it makes sense to do that activity as well as you can. And then beyond that, the one lasting representation of the code that's working is actually the code that you wrote. And, documentation can get out of date, especially external documentation. And so for that reason, too, it makes sense to focus on making the code as high quality as possible. I think one of the misnomers that we run into in the software world is the idea that coding is a solo activity where people just write the code themselves and nobody else ever sees it. And of course, as we've seen a greater emphasis through Agile with collaborative practices, we more routinely see lots of people going over the same code, maybe not revising it directly, but needing to understand it. And so, to that degree, coding becomes more of a collaborative activity where we communicate with other human beings through the code. And to hear you make the comment you make about DevOps focusing on the software craftsmanship and the quality of the code is to my way of thinking, a very well-placed emphasis. I thought the same thing happened as we started to see, we're going back 15 years ago now, but as we started to see more of an emphasis on security, an awful lot of security also comes down to high-quality code.
Yeah.
Where the security breaches come from exploiting known weaknesses or defects in the code. Well, a big part of the antidote to that is write code that doesn't have the defects in the first place, and that all goes back to the subject of Code Complete.
And I suppose, and so I love that. You're absolutely right. So coding is an activity that always gets done. You can't avoid it. You can't build a product without doing some coding. And as you say, it's the one thing that's guaranteed to last afterwards as well. Documentation may get written or may not get written and may go out of date, but the code is always the current up-to-date representation of the software. So yeah, and I think it's heartening for me as well to see that that's been or continues to be reinvigorated as important, and we saw it in Agile, and we now see it with DevOps. I think before we move on from Code Complete, I've got to just mention the fact that there is a passage from the book that is truly famous. I don't know if you want to, do you want to describe this and how it came about? Or?
Well, I know which passage you're talking about. And yeah, so there's a passage from the book that was used in a TV ad, not a very good TV ad, but a TV ad with Bill Gates and Jerry Seinfeld. So I actually have video proof that Bill Gates has read my book. He's actually reading it to a baby, but yeah, he's reading it literally to put someone to sleep. But yeah, so I have proof that Bill Gates has read my book.
So I think you're right. Yes, in the advert, it's like being read as a bedtime story, isn't it? And we've never done this before, but I'm going to try and now cut in just the clip of that so that people know what we're talking about.
The fact that a design uses inheritance and polymorphism doesn't make it a good design. The rote object...
Are there any monsters in the story?
Yes, but it's okay. There's a firewall.
Okay, so we'll come back from that.
Right.
So I think, again, I mean, you've written a number of books, and several of them I've read cover to cover. There was Code Complete, was one of the first ones. There was Rapid Development, which I have on my desk just to prove it. But later on in my career, I probably shouldn't admit to this in public, but I did some dreadful software estimation, and it caused a lot of problems on the subsequent delivery. And at that point, a little bit like closing the stable door after the horse has bolted, but I bought your book, Software Estimation, Demystifying the Black Art. So again, perhaps, because I think you've become known as the person that wrote the book on software estimation. So perhaps you could tell us a little bit about why you think software estimation is important, and maybe some of your ideas about how to go about it.
Yeah, sure. Well, I think, software estimation to me is an interesting topic. To me, it's a fascinating topic. It's actually the topic that got me interested in more systematic approaches to software development in the first place. Before I was even interested in the subject of Code Complete, I was actually interested in the subject of software estimation. That's what led me into the body of literature that eventually exposed me to the background work for Code Complete. I think the interesting thing about software estimation is if you're estimating well, it really means that you're doing a lot of other things well too. It does mean that the estimates per se are probably pretty good, but if your project is perceived as being a well-estimated project, not only do you have to do the estimation work well, you actually have to control the project well and execute the project well. So if I go into a company and see that their estimates are good, that tells me a lot of other things are good too. If I go into a company and see that the estimates are bad, it could possibly be the case that lots of other things are going well and it's just the estimates that are bad, but usually it means that there are lots of other things going not as well as they could either. So to me, estimation ends up becoming a window into overall software development effectiveness, and as such, it's a really fascinating topic. I think that the discussion really needs to start with, why do people need estimates, or why do organizations need estimates? And a lot of that depends on where you are in the project. If you're still at the sort of product definition phase, or conceptual phase, or budget approval phase. Sorry, my lighting just went off. So this is the hazard of being in an energy efficient building. So if you're in the very early days of a project, then the entity that needs the estimate is the business. It's not an entity internal to the project. It's external to the project. It's the business stakeholder, the finance group, the marketing group, the sales group. And so at that point in the project, it doesn't really matter whether you're going to do the rest of the project in an agile way or a waterfall way. The estimation approaches are basically the same, regardless of how you're going to execute the project. And the drivers for the estimate are outside the project team. We've unfortunately seen numerous instances where agile initiatives get shut down because in those early days of the project, the agile team refuses to give estimates to the business. And I think that's unfortunate. We've seen businesses that could really benefit from specific agile practices, and in this case, I'm really thinking of Scrum, where the team has been not allowed to use Scrum because of what I see as really ancillary aspect of that, which is refusing to provide business level estimates. And I think mostly the motivation from that, for what I've seen, is simply a lack of skill. People just don't know how to create estimates. You often see statements like, good estimates are impossible. They're not impossible. They're impossible if you don't know what you're doing. And even smart people can't really intuit what they should be doing with estimation at this point in time. There just have been too many really smart people who have already looked at this stuff and been figuring it out for the last 40 years. And so, it takes actually learning some of what has already been done before people are going to be able to do it. Once the project is underway, then I think the nature of estimation changes quite a bit. If the project was well estimated early, and the estimates are meaningful estimates, and a lot of times they're not, but if they are, at that point, the purpose of estimation really is an internal purpose, and the estimates are mainly focused on the team itself. So they're used for managing the detailed flow of the work, for tracking whether you're performing according to plan. If the early estimates were good and it's possible to perform to plan, those estimates don't necessarily ever get surfaced outside of the project team. Really the only time the estimates get surfaced outside the project team is when the estimates reveal that you're not performing according to plan. And that can be either because the project is being executed poorly, which sometimes happens, or it can be because the original estimates were bad, which happens at least as often. So I think just getting clear about, who's asking for the estimate, what are they going to use it for? And then I think one of the really common estimation mistakes people make is thinking that there is one good way or right way to estimate regardless of where you are in the project. And that is just not the case. And I think that line of thinking leads people to say either estimation doesn't work because they tried to apply the wrong kind of practice at the wrong part of the project, or estimation is way too labor intensive, again, because they tried to apply the wrong kind of practice at the wrong point in the project. But if you know what you're doing, estimation doesn't take that much work, and can be quite meaningful regardless of where you are in the project.
So, and because you've talked a little bit there about the different, I suppose, stages of the life cycle of a project, could you perhaps reveal a little bit about the estimation cone of uncertainty, which again is a concept that I think is fantastically useful to share?
Yeah, so the cone of uncertainty is the idea that as you work your way through a project, there are sources of variability that come into a software project. And the variability is things like, in general, what is the customer going to want? In general, how much money do they have to spend on it? In a little bit less general or a little bit more specifically, what kind of requirements do they have for the project? How many are there? How big are they? And then as you get into the detailed inner workings of the project, what specifically does the customer mean by this exact requirement? What are the detailed ins and outs of this? What test cases do we need to write that would show that we've actually met this requirement?
Yeah.
And so basically, in the early days of the project, we have all kinds of variability feeding into the project. We don't even necessarily know who's going to be working on the project or how productive they are, or necessarily even who all the customers are for the project. And so because we've got so many sources of variability, our ability to estimate a project that has that much variability is pretty limited. And that's not really an estimation limitation. It's just a description of how much variability is in the project at that point. And so if we think of it conceptually about how much range would we have in our estimate to accurately capture that variability, in the very early days of the project, the range is enormous because we've got, we don't know who's on the team. We don't know all the customers. We don't know all the requirements. We may not even know in general terms what we're trying to accomplish. By the time we're well into the project, we know who's on the team. We can know how productive they are if we're collecting the right kind of project data, velocity being the most common example. We presumably have a much better idea of who the customer is, and at least a pretty good idea of what kind of requirements we're getting from them. Depending on how iterative or sequential we're being, we may have lots of the requirements, or we may not have them. But if we could either have most of the requirements, and that's one way of reducing variability, or we could have really good velocity numbers and a budget in terms of how much time we have or how many story points we can deliver in the amount of time we have. So that's another way of reducing variability. But anyway, by the time we're in the middle of the project, we can reduce that variability dramatically. And so this idea of the variability being really high in the early part of the project and being reduced by the time we get into the middle of the project is what I've called the cone of uncertainty. I think one of the common misnomers about the cone is that it suggests that there's a guarantee of improved estimation accuracy as you get into the project. I don't think anybody's experience has ever borne that out. I mean, we've seen thousands of projects run in such a way that you don't get a cone of uncertainty, you get a cloud of uncertainty. Nobody really knows when the project's going to be done until it's actually done. So the cone is a prospect of improved estimation accuracy or reduced variability. It's not a promise, but a prospect.
Yeah. And I suppose that's too. I can almost remember the exact phrase in the book. It says something like, "The cone is showing you the best possible precision you can hope to have when you're doing good estimates using data and skilled estimators." And I think you say it's basically impossible to be more precise at those stages. It's very easy, to do worse.
Yeah, and I think the key point there is there's an interplay that really matters between estimation and project control. It's not possible to estimate better. It is certainly possible to control project parameters to come to an outcome that everybody finds desirable.
Yeah.
I can say, okay, we're a third of the way into the project. We think this thing should come out between 6 and 7 months, and we're just going to control it. We're going to manipulate the feature set and the schedule. So we declare whatever we have at the end of 7 months, that's the product. Okay, fine. If we have that approach, our estimation on schedule is going to be pretty good because we're going to be done at 7 months. And, is that really estimation? Well, to my way of thinking, no, it's more control than estimation, because if we're saying that we're going to flex the feature set infinitely to conform to our schedule target, that's a perfectly legitimate way to run a project, but it's not estimation per se. And I think there are a lot of times when, if you work your way into the project a little bit, like maybe a third of the way in, we actually can make quite an educated guess at that point about what combination of cost, schedule, and functionality we can end up with. And then we can make minor tweaks in those to steer the project toward a successful conclusion. I think there's been some estimation in that scenario. There's also been some control in that scenario, but I'm pretty comfortable saying there's a combination of estimation and control. And that combination is really what businesses want, I think. There's really no such thing as pure estimation in the software world, because we never end up delivering the exact thing that we estimated. We always end up having people go on vacation that wasn't anticipated, or adding features or subtracting features or modifying features. So we never end up delivering exactly the same thing that we estimated. And as such, it's really analytically impossible to say in a really pure way that this was a good estimate. And for that reason, that's why, as I point out in the book, my definition of a good estimate is more of an operational definition than an analytical one. It's really a good estimate is one that gives the project leadership a clear enough view of the scope of the project and the level of risk on the project, so that they can effectively control the project toward an outcome everybody views as desirable. But that's not a very pure definition. It really is more of a functional, operational definition.
Yeah, and I think as well that it is the estimation, or certainly I feel that it's the estimation that often the quality of the estimation sets up how you can run the project, and also to some extent sets up whether it will succeed or fail. Partly because of course, if you radically underestimate and no one appreciates that that's because of uncertainty, then it will be deemed a failure no matter what you do. But also because I think having a realistic plan, that's what then allows you to respond to changing circumstances, or if someone goes off on leave unexpectedly, you can respond to that if the plan is realistic at the outset.
Yeah, I think that's right. And, we just don't get away from this idea that there's an interplay between estimation and control. When I was editor-in-chief of IEEE Software, one of the columns I wrote, which is one of my personal favorites, was called Sitting on the Suitcase. And the idea was that software estimation is not about exactly estimating with pinpoint precision the exact combination of cost, schedule, and functionality. It's more like packing for a trip, where if I'm going on, say, a 5-day trip and I really want to pack all my clothes into a small suitcase, I pick out a suitcase I think the clothes are going to fit in, I stuff the clothes in, and hopefully they fit. Okay, that's good. My control worked. But if they don't quite fit, I might end up trying to jam the suitcase closed to make the clothes fit in the suitcase. I might end up sitting on the suitcase and trying to zip it shut with some force on it. And that might work. And if that works, great. I accomplished my objective. I still took that size suitcase on the trip. But every once in a while, I'm going to sit on the suitcase and it's not going to work, and I need to get a bigger suitcase. And so that's to your point of, if I estimate the project and I'm pretty close, then I can probably handle things like somebody going on a little bit more vacation than planned. But if my estimates are too far off, I'm not going to be able to fit the project into the size of container that I estimated it, where the container is either a team size or a schedule or a budget or all the above. And so really the point of estimation, I think, is, what size suitcase do I need? Can I do something reasonable for the business that provides more or less the business value the business is looking for with this combination of cost, schedule, and rough functionality? And if I'm estimating well, then everything can work out fine. And I think most businesses actually have, adults running them, and adults can realize that you don't always get exactly everything that you wanted. But if you get pretty close and people feel like you're operating in good faith and you're being competent, people are fine about the idea that we didn't get exactly what we wanted. It's only when you're not even getting remotely close to what you wanted that people start to get upset. And unfortunately, in software, we have a long history of companies not getting remotely close to what they wanted. And the reasons for that are manyfold. One reason I think is teams aren't always as competent as they could be, and that's really kind of why I wrote Code Complete. Another reason is there are these organizational pathologies about how, I don't even think of it as estimation, I think of it as the commitment process in the organization, where in the absence of good estimation skills, a lot of times businesses will just say, here's your combination of cost, schedule, and functionality, go do this. And since the teams don't have good enough estimation skill to confidently push back on that, they kind of get stuck going on a mission that everybody has a vague feeling is just not going to work. With good estimation, you can do a lot better than have a vague feeling that it's not going to work. You can go back to the business and say, hey, we realize that this is what you want, but here's our estimate that says, you can either have this schedule and these other features, or you can have these features and this other schedule, but you're not going to get both. And you can say that confidently on the basis of historical data. In my experience, if you actually have some backing for it, the business actually is glad to hear that. I mean, you can't expect them to be happy that they're not going to get everything they want, but you can expect them to be grown-ups about it and say, yeah, I'm glad we figured this out now and not 6 months from now.
Yeah, I'd rather exactly, and I think people do. They'd rather know up front. And I remember in software estimation, I think you have a dialogue between someone who's prepared an estimate, and it's a chapter on communicating estimates. And so I'm conscious of time. It's also fascinating. There's two things I really just still would like to ask you about, and one is you mention in the book the difference between accuracy and and precision on an estimate. Right. So again, if you could just explain that, because I think it's a really useful concept for people.
Yeah, sure. I think in common speech we talk about those almost as synonyms, but they're really not. Accuracy refers to did we hit the mark at all, and precision refers to how closely did we hit or miss the mark. So like a good example of precision without accuracy is airline flight times. Airline flight times are scheduled to the minute, but does anybody think that they actually are accurate to the minute? They're not, right? Your flight could be half an hour late or an hour late. So the accuracy on airline flight times might be plus or minus half an hour, but the precision is to the minute.
Yeah.
And for estimation purposes in software, the key point is that people make assumptions about accuracy based on the precision with which a quantity is expressed. And so if we go back to our business partners and say, our estimate is that this functionality can be delivered on August 17th, then that implies a level of accuracy because the precision with which that deadline is being expressed. If instead you go back to the business and say, we really see this as being delivered sometime in third quarter, probably late third quarter, well, from an accuracy point of view, the person might be thinking the exact same accuracy in the back of their minds, but from a precision point of view, they've expressed that quantity quite differently. And now the person receiving that number is going to make different assumptions about the accuracy as well as the precision.
And I think that's the thing, is that if you see something presented as it will take 509 days and 3 hours, then that suggests you have a high confidence in exactly how long it's going to take. Whereas it might be more realistic to say 500 days plus or minus 25%. I don't know. But
yeah, depending on where you are, 500 staff days could be 2 staff years, and you might express it that way.
Yeah. So I think, and it's certainly that's been useful for me is thinking about how confident are you, and then presenting the estimate in a way that represents that level of confidence, because also it leads to a more intelligent discussion then around risk, really, around the risk
Really.
associated with it.
Yeah, and I think the key point there is it's not that you should avoid using precision, it's that you should avoid using precision that overstates the level of accuracy. So there will be a point in the project where you can get to it and say, I mean, in a well-run project, there will be a point where you can get to saying, we really think we're going to be done as of this specific date.
Yeah.
And so at that time, you need to actually start talking about that specific date. But very early in the project, you probably have no business talking about a specific date because you just don't know enough at that point.
And so one thing, and I don't know whether this will be controversial or not, but I think something that is topical at the moment is the whole no estimates movement around Agile and DevOps. This idea that time spent estimating is effectively waste. It doesn't add anything to the product. So as someone who has written about estimation and knows a lot about the subject, perhaps you can just finish off with giving us your view on that.
Sure. Yeah. I think the idea that estimation is waste, if you think estimation is waste, then there are two reasons to think estimation is waste. And the main reason is because you just think it doesn't work. And if you think it doesn't work, then of course anything that doesn't work is going to be waste.
Yeah.
The other reason that a person would think it would be waste is because it's not actually code. And so if that's the reason that somebody thinks it's waste, then you're basically saying anything that helps the project run more smoothly, but that is not actually code, is waste. And so by that line of reasoning, talking to the customer would be waste, testing would be waste, anything that's not generating code would be waste. I just think that's a bad argument on its face. So really, I think the legitimate argument here from a logical point of view is that estimation just doesn't work, and so it's waste. I think that's largely a function of people just not having good estimation skills, and that goes back to what we were talking about at the beginning of the segment, which is if people are just trying to make it up as they go, or they watched a 3-minute YouTube video on something, then they're not going to be able to estimate effectively. The skill is not that simple. Mm-hmm. It's not a hard skill once you learn how to do it, but it's also not intuitive, and it does take a little bit of effort, maybe more than a little bit of effort, to learn how to do it well. When you get to the point where you do learn how to do it well, then I think it contributes to a project running more smoothly in the circumstances where the business values predictability. And that, I think, is most business circumstances. Most businesses, to authorize spending of money, want to have some idea what they're going to get for their money and when they're going to get it. And in order to provide that, you need to be able to do some effective estimation. There are cases, I think it's minority, but there are cases, and some of them are important cases, where the businesses don't value predictability. They basically say, here's our team, and that's not going to change, and we don't care about the schedule because our mission is just keep cranking stuff out as fast as we possibly can. And this, I think, does apply in a continuous deployment kind of setting, where if our mission really is just do the next most useful thing and deploy it on a daily basis, yeah, I can see that in those circumstances, we don't need to spend time estimating. I mean, what is the point of that? I think if our granularity of our work is daily or even maybe weekly, and the focus is just do the next most valuable thing, and that's a viable business strategy, which is really the big question mark, then yeah, I don't see any real reason to have estimation in a context like that. Maybe at a gut feel level just for managing personal workflow, but I'm fine not calling that estimation. But I think we need to be really clear that that is the scenario that we're working in. And I think for all the discussion that you see on this topic, you would think there were a lot more scenarios where that is the scenario than really exists. Yeah. And so my main comment on this is just validate your assumption with the business. One of the Agile values is supposed to be customer collaboration. And so, go talk to the customer and see if they really don't want estimates and they don't care about predictability. And if they truly don't, then fine, that's good customer collaboration. But, if you assume it, then you're not collaborating with the customer. And if you go talk to the customer and they say they want predictability and you don't provide it anyway, that's not collaborating with the customer either. So, the bottom line here for me is find out what the customer wants and either give it to them or develop the skills that you need to deliver it to them if you don't already have those.
And it's just to add to that, because I do remember I gave a talk earlier this year, and afterwards someone working for a startup that was VC backed came and talked to me, and you realize that even a startup, if there is investment, there is usually someone saying, and when will the MVP ship, and when will you? So I think it's probably a very small subset of businesses where it's the owner is the kind of lead developer, and there is no external investment, where you will perhaps be willing to accept very low levels of predictability. Although even then,
I think there are cases, especially in new markets, where there are companies that are basically making money faster than they can count it, where and I'm thinking in particular of the mobile space the last few years, where the mission really is just crank out the functionality and try to create the most appealing product and grab market share. And nobody really knows what 3 months from now looks like anyway. And so let's just keep doing the most valuable thing we can. And 3 months from now, that'll look so different from what it is today that there's no real point in trying to plan any further out than that. And I think that's a characteristic of an emerging market. It's a characteristic of bleeding edge technology. And so there's a role for that. But I don't think, and for the people who live there, that's great. That's a good approach. But I think we need to be careful to identify whether that's really where we live, or maybe where we want to live, but we don't actually live there. And like you said, even in the VC environment, I was an expert witness in a lawsuit that really turned on this particular topic, where you might think in a startup environment, we're just doing the next most useful thing. That is, in fact, what the vendor company tried to do in this lawsuit. And basically the funding party ran out of money because they kept doing the next most useful thing, and they didn't get to a viable product with the amount of money that they had. And the estimates were awful. And the VCs probably would not have spent the money, period, in the first place, if they had gotten a clear idea of what functionality they could get for what amount of money. So yeah, even in that environment, I think estimation is important, and the people who are spending the money think it's important.
Fantastic. So usually I get people to talk a little bit about the background and what they're working on now right at the start, but since we dived straight into software craftsmanship and estimation, I didn't do that. So maybe just quickly, you could just let us know, something about Construct, your company, and what you're working on, and just so that people have that information as well.
Yeah, sure. So after I wrote Code Complete, I spent several years working as essentially an independent contractor, and I enjoyed that. I got to see a lot of different companies, and I learned a lot. But eventually, I got tired of working by myself and seeing different faces all the time. So I started my own company, Construct Software. We provide consulting and training. About 2/3 of our business is training, and 1/3 is consulting in the area of software development best practices. And so an awful lot of that these days is Scrum, Kanban, Agile practices. Some of it is still estimation and more traditional project management, developer testing, and that kind of thing. We've made a big push in the last few years into online training. So if you go to ondemand.constructs.com, that's actually a portal into our online learning site. For me personally, the project I've been working on most recently is a lecture series. I'm not working on any new books, but I am working on a lecture series called Understanding Software Projects. And you can view the current lectures for free in that series. I'm putting out new lectures every couple of weeks, and so the new lectures are always free in that series. Really what I'm trying to do with that series is kind of similar to what I was trying to do with Code Complete, where with Code Complete I was trying to distill knowledge that somebody needs to be an effective programmer at the detailed software construction level. With Understanding Software Projects, I'm trying to distill what I've learned really over the last 30 years about how to run effective software projects and what the key project dynamics are. And I'm presenting that in the lecture series. So I think the lecture series is pretty cool. I think a lot of the concepts are not concepts that I've published before or that anybody else I've seen has published before. So if you're interested in getting a insight into how software project dynamics work, I think it's a pretty cool lecture series.
Well, I'll definitely be watching them, and we'll add a link when I post this video online so that people can click straight through to that. Steve, thank you so much again for your time. That was fascinating for me. I'm sure it will be for other people. And I'm really looking forward to the discussion on Twitter as well.
Well, again, thank you for having me.